Calorimetry or calorimetry? How you say it?
Calorimetry.
Calorimetry.
All right, molarity. Do we see, when we see the big M's on the bottles of reagents that we use in the lab, that big M stands for molarity. That molar, huh?
You know that.
What?
You know that.
I don't know, that's an inside Petri dish joke. Okay? So, molarity simply means the concentration. How much of that substance is in your solution? Correct?
Oh, you was wondering, is density? No, okay, that's fine.
Wait.
Are you finish your sentence
Ask
though?
a question, cuz.
What
What was
was it?
it?
Is density kind of the same as molarity?
No, ma'am.
Oh, it's okay. So we were saying. Oh, that's what we were saying.
You were saying.
Okay, so molarity is moles over over liter.
Math?
Right. So is density, right? But what's the difference in what you're finding?
Density is how compact something is.
And is it intensive?
Density.
Does that matter?
What,
The
density?
properties? Or
Yes.
So, what is this considered?
Molarity would be extensive.
So they differ in the properties.
Yes.
And what was this again? Why?
Molarity is concentration. How much you have of your substance in your solution.
Right. So say for instance, I know they're comparing two different things, but why do they have the same?
Formula?
Well,
Pretty much.
remember, density is grams per milliliter. Molarity is grams per liter. I mean moles per liter, sorry. So
Oh.
it's not the same units.
Okay.
Okay?
Grams. So we have moles over liter versus
Moles over-
grams over liter.
Milliliter.
Milliliter.
Okay? Now, you can have two of the same solutions with this different molarity and they behave completely different. Okay?
I thought it said grams of solute over milliliters of solution. That's not right.
That's density.
That's density. That's not molarity.
That's not molarity.
Okay.
I was looking up the pH value of calcium carbonate, and I
Okay.
saw a chart with different pH values according to volumes. It had like 1 M, capital M, 10 M. Is that
Molarity. Yes.
I'm gonna do that right now. Like get interrupted.
Sorry.
Okay? So, let's take HCl for example.
That's how we know it's a base.
Hydrogen, huh?
As I was saying, like that's how we knew it was a base because the pH value.
Right, yes. So, hydrochloric acid, concentrated hydrochloric acid is 12 molar. Right? The hydrochloric acid that you guys use in the lab.
Well, what do you mean like 12 moles?
Okay. Just trust me here. Okay? Trust me for just a tiny little bit of seconds. Okay? So where you guys were cleaning your flame test wire, what was the concentration? It was the molarity there.
Is it 1
No. No.
That's 1 to 3.
It was 6 molar HCl. Okay? The one that you used in your experiment
It was the 0.1.
was 0.1 or 1 molar. Okay? These are all HCl, but you have different molarities. If a 1 molar HCl solution falls on your skin, you can rinse it off, you'll be fine. Might just itch a little bit, but you'll be fine. 6 molar HCl drops on your hand. You go on. You will end up with a first degree burn. 12 molar HCl drop on your hand, it will eat through your hands. There's no stopping it from doing that. You can rinse it, but it will still eat through your hands. Okay? When you open a container of 12 molar HCl, the fumes and the gases that's released burns your nose, burns your eyes. This is how strong and powerful 12 molar HCl is. Okay?
Are you,
Huh?
are we using that by any chance in lab?
12 molar? No, ma'am. No, ma'am. You been trying to burn me up. You see my pretty brown skin, child? Okay? Concentration can be discussed in molarity or percentages. Have you ever looked on, you get like a medicine from the doctor or like cough syrup or something, and you see a number W/W or V/W.
Volume per volume.
Volume by volume, or volume by weight, or weight by weight. This is what percentage is about. I'm not allowed to teach percentages, so we gonna stick with molarity. Okay? Now, molarity is simply the moles of your solute divided by the liters of your solution. Do we get that? That will never change. You can use units in two ways. You can either put the big M, or you can write moles per liter. Do we get that? Okay.
That'll be N/L?
Yes.
Big M.
Big M.
Big L.
Actually, I lied.
Moles is
ML.
MOL. Yeah. So here's an example. A 250 milliliter sample of solution contains 0.134 moles of solute. Calculate the molarity of the solution. What is the first thing we must do?
Milliliter terms of.
Very good. Convert your milliliters to liters. How much is 250 milliliters in liters?
0.05.
0. What? 0.55.
0.25.
Oh. 0.25 liters.
Over.
Right? So now what do we do?
Mole over liter.
Moles over liter. So what do we have? What is my molarity?
0.134 mole over 0.25 liter equal to
0.536
0.
Hmm?
0.536 mole per liter.
Yeah, 0.536 mole.
Very good.
I can just put 0.536 molarity at the big M.
Big M, yes.
Big M is molarity, right?
Big M, yes. Do we get that?
It's not gonna look like that on the test, though, right?
Of course, why not?
But
It is. I'm telling you. Would I try to trick you?
You say it like that.
Alright, let's take another one. Okay? 9.45 grams of methyl alcohol or methanol was dissolved in enough pure water to give 500 milliliters of solution. What is the molarity of this solution? What do we need to do?
Make it gram to mole.
Very good. Convert grams to mole. What do we need in order to convert grams to moles? The molar mass. How do we calculate the molar mass? Add. What is the molar mass for my methanol?
That says 945 grams?
No, sorry.
36 grams.
9.45 grams. How much?
36.
36?
Yeah, carbon is 12, hydrogen is 1, oxygen is 16, so 4 plus 12 is 16, and 16 32.
But she said 34.
I made 32.
There you go, and you're right.
Yeah, 32.
So it's minus 2.
32 grams.
There you go. 32 grams per mole.
Yeah.
So how much is 9.45 grams in moles?
0.2625. 0.2625.
0.29?
26.
Not 29.
0.295 moles.
It was 9.45 divided by 32.
Yes. Yeah, Alright. So now that you have your moles, what do you do?
Divided by the liter.
divided by liters. How much liters do we have?
0.5.
Very good. So what is my molarity?
0.59 million.
0.59. That's what we got?
0.5.
That's what I got. Are we getting it? No? Questions, comments, inquiries? No? Okay. All right. Mixing a solution. When you are making a solution, because you will have to make solutions come Thursday. Thursday you have to make your own solutions. All right?
Like whatever we choose.
No, not whatever you choose, whatever I tell you to make. Okay? So, given that we want a particular molarity of a solution, okay? If you know that you want 0.25 moles of copper sulfate, what must you do in order to figure out how much you need for that?
You want 0.25 mole?
Moles of copper sulfate, that's my solution. How do you know how much you need to, how much copper sulfate you will need?
You calculate it,
How do you calculate it?
get the mole by grams, then make it 0.25, something like
What do you have to convert to?
that. Molar mass?
You have to convert to grams,
Yeah, molar mass.
okay? So you find the molar mass of your copper sulfate, you convert your 0.25 moles to grams, and that's how much you weigh out on your balance. Then you need to know how much solution are you going to be making. Whatever this here is your volumetric flask. This is a 500 milliliter volumetric flask. You're ultimately going to make 500 milliliters of a 0.25 molar solution. So you're going to place how much you've weighed, your mass of your 0.25 molar into your volumetric flask, and then you fill it up to your 500 milliliter marker. That's all you mix in a solution. Did we get that? Okay. Now we have dilution. This slide is a little cumbersome. Dilution is simply making a lower concentration solution from a higher concentration solution. That's all it is. Okay? So, in the book, we have MC times VC equals MD times VD. I don't normally use that. I use C1, V1 equals C2, V2. It's the same thing. Okay? On your left-hand side, your C stands for concentration. Your V stands for volume. That's for both sides. Okay? But on your left-hand side, this is your solution, the solutions that you have. You have this. So this is your higher concentration. On your right-hand side, this is the solution that you want. This will be your lower concentration. Right? Now, C1 is the concentration that you have. C2 is the concentration that you want. V2
This is for dilution of the.
Dilution, this is only dilution. V1 is the volume of C1 that you need to add to get to C2. Okay? Let's take a question first. We'll see what it is, right? I would like 100 milliliters of a 2.5 molar HCl solution from 7 molar HCl. So, what is C1?
2.5.
Seven, the high concentration.
7 molar, very good. The high concentration would be on your left-hand side.
That's not we have.
This is what you have.
Oh, we want.
This is
that-
what you want.
Oh yeah.
You can't go backwards. So C1 can never be lower than C2.
Okay. Higher.
Alright? Yes, must always be higher.
Higher.
What is V1?
That's what we want.
That's what you want. So this stays the same. What is C2?
2.5.
2.5 molar. What is V2? 100 milliliters. Very good. So now we're going to plug this in. 7 molar V1 equals 2.5 molar times 100 milliliters. Solve for V1. What do we have?
35.71.
35.71 minus 2
Milliliters.
milliliters.
And how exactly did you do that?
Look at it. Multiply this by this. What do you get?
250.
250 molar ml. 7 molar V1. How do you solve for V1?
Divide by 7 and
Divide by 7 molar on both sides. Molar cancel out. V1 equals 30 what?
35.71.
Milliliters. So this is how much of your 7 molar you need to add in order to make your 2.5 molar. Yep.
That's the one.
Not with these. Okay? So here now, what does this volume mean though? Okay? We have to know what this means. V1, remember your total volume is 100 milliliters. You need to now add 35.71 milliliters of your 7 molar HCl to how much water? No.
You subtract it from 100.
You're going to subtract this from 100. So how much is that? That look like 60 something.
29.
So you're going to add 35.71 milliliters of your 7 molar plus 64.29 milliliters of water. This will now give you your 2.5 molar HCl solution.
100 milliliters.
So volume 1 is 64 point,
No.
volume 1 is 35.71.
Yes.
Isn't that what you were trying to find all along?
Yes, that's what we found.
Okay, so that extra step is just to find,
This is, if I create this in the lab. You would have to tell me you're adding 35.71 milliliters of your 7 molar plus 64.21 milliliters of water to give you your C2. Okay? Now you're going to get kind of deep. Okay? More deep. We going to involve my stoichiometry. Okay? Now, we can use our molarity and stoichiometry. You see the titration that we did? This is kind of what we're talking about. This is what's happening. You can figure out the concentration of one of your reagents based on stoichiometry. Alright? So, again, same thing that we've always done. We will always go from grams to moles. If you're given grams, you must find moles. From your moles, moles of one reactant, you can use stoichiometry to get the moles of other reactant. Then you can either go to volume or you can go to molarity. Okay? Let's take a question. Alright? Remember, stoichiometry. What are the units for molarity?
More 1 gram.
Per liter? 1 liter.
Mole per liter.
Yeah.
If I give you volume, can you find moles from molarity?
Volume to mole?
Yes. If I give you volume, can you find moles?
Mole.
How? What do you need? No.
Volume.
If I give you volume,
Only volumes.
or all I give you is a volume, what would you need in order to find moles?
The weight?
No. What is a conversion factor that has the units moles
Gram.
and volume? And volume.
Molarity.
There you go. So if I give you volume, you can find moles just by using the molarity. Okay? Here's the question. How many grams of sodium hydroxide are needed to neutralize 20 milliliters of a 0.150 molar solution of sulfuric acid? What is the first thing we do?
Is that the formula?
The formula.
That is not what we're doing there, no.
Something before that.
Molar mass.
Turn the milliliters to liters.
Not grams.
Before that. Before that.
Making
Nope,
conversion.
before that.
Ay, Dios.
There you go. You write out the chemical equation. We must always write out the chemical equation. What is my chemical equation here? H2SO4 plus
Sodium hydroxide.
sodium hydroxide produces
Salt and water.
salt and water. What's my salt?
Sodium sulfate.
Sodium, what's the formula? Na2SO4 plus H2O. What we got to do next? Balance the equation. How do we balance the equation? What's my coefficients?
2 equals sodium.
2
Equals sodium.
and sodium.
Sodium hydroxide.
Sodium hydroxide. 2, is that it?
Give me a second. And then 2 and oxygen. Oxygen gas.
Yeah. Water.
Mohammed, you are not here today.
Yeah, because I don't understand because hydrogen is higher than the sodium. In the like. What?
Activity series.
Activity series.
What?
Hydrogen is higher than sodium. Potassium. Or potassium is the higher than the sodium, calcium, whatever. I'm done.
Okay. Okay. Step 1. Write the balanced chemical equation.
Yeah.
Okay.
2.
Step 2. What do you think step 2 is?
Get the molar mass.
Nope. Step 2, convert your milliliters to moles. So, if we're converting your milliliters to moles, what do we need to do?
It's molarity.
We use the molarity. So what goes on the outside?
Molarity. Sorry,
So is need to be milliliters?
Liters.
Liters. So what's the liters? What's 20 milliliters in liters?
0.02.
0.02 liters. What's the molarity? This is
moles on top.
H2SO4. How many moles?
0.15.
0.15 moles H2SO4
For 0.001 liter.
What is the units for molarity?
Oh, mole per liter, so 1 liter.
There you go. Alright?
Mole per milliliter.
No more per milliliter. So you cancel out your liters. Multiply across, divide by the bottom. How much moles do we have?
0.3.
0 point?
0.03.
0.003.
0.003. That's what I got too. So now you have moles of sulfuric acid. What do we need to do next? What's step 3? There you go. How many moles of sodium hydroxide do we have?
2 more.
What do we need to do? In order you have moles of sulfuric acid, how do we find moles of?
Ratio.
You have the mole ratio. What's the mole ratio? 1 to 2. So therefore, how many moles of sodium hydroxide do I have? So let's set it up. So we have 0.003 moles H2SO4. Bracket, what goes on top? How many?
2.
2 moles of NaOH.
1.
1 mole
Oh.
H2SO4. Cancel out your moles, H2SO4, multiply across, divide by the bottom. What do you get?
0.006.
0.006 moles of sodium hydroxide. Now, what are they asking you for? Grams. So now we have moles of sodium hydroxide. What do we need to do to get grams? Convert your grams to moles. What is 0.006 moles sodium hydroxide in grams? How much? What's the molar mass for sodium hydroxide? 40 grams per mole.
40 grams per mole.
So it would be 0.24 grams of sodium hydroxide.
That's what I got. Can we get that? All right.
Hold on, you put the 40 grams on top, right? Is that so that-
Yeah.
All times.
Okay. So now, the same titration that we did in lab, this is what we're doing now. Okay. Same type of math that you did for the titration experiment. This is what we're doing again. Okay. So we're now incorporating these steps. These steps will hold true for any time that you have a, okay, let's back it up a little bit. How are we going to identify to finish. Anytime you have a stoichiometry or titration type questions, you always have two different substances. You must follow these steps in order to solve any stoichiometry equation with two different substances. Dilution, you only have two of the same substance. Right? Now, titration. What's titration for? What do we use titration for? No. What was the purpose of titration?
To find the molarity of a,
Unknown
find the
sub-
unknown molarity of
Very good. So you're trying to find the molarity of an unknown solution. Okay? So again, same steps that we've done, but now in the end, instead of finding grams, we want to find molarity. So here we go. What is the molarity of a sodium hydroxide solution if 48 milliliters neutralizes 35 milliliters of a 0.144 molar sulfuric acid solution? Step 1,
Equation.
equation. Step 2,
Balance, yeah, balance already.
that's all in step 1.
Yeah. Convert.
Very good. Convert milliliters to moles. You have 2 milliliters here. Which milliliters are you going to use to convert first?
You know, what is
Hmm?
sulfuric acid? Sulfuric acid, because we know the mole of them.
There you go. Your one that is associated to the molarity that is given. So you convert your 35 milliliters to liters and then convert that to moles. How much moles do you have of sulfuric acid?
0.144.
Convert it to moles or molarity?
You convert it to moles by using molarity.
0.0504.
0.035 into 0.14.
How much moles do we have?
0.00504.
Very good. What is step 2? Step 3, sorry.
So we're gonna find out. The ratio.
Compare, right?
Compare.
No compare.
The-
You're going to convert moles of sulfuric acid
Sodium
to moles of sodium hydroxide using, no,
A mole per
no,
liter.
huh?
Mole per liter.
No,
The ratio.
the mole ratio. You're going to use stoichiometry to figure out the moles of sodium hydroxide. So how many moles of sodium hydroxide do we have?
2.
The one.
0.01 mole.
0.01008
0.008.
moles. Now you have your moles of sodium hydroxide. What's the next step?
Get the molarity.
Get the molarity. How?
Just divide by the 0.048.
There you go. You divide, you use your moles to convert to molarity using your volume for your sodium hydroxide. So what's the molarity?